Well, thanks everybody for, thanks Stuart for such a warm introduction, and thanks for the warm welcome. It's great to see lots of familiar faces in the room, but also lots of new faces. And get to know you all and build another bridge maybe in this Boston space network. So I am an HES, I'm an economist by training. Yes, there's the book. Right, so I'll talk a bit about the book, but what I was hoping to do today, so I'm not a rocket scientist, I'm not a medical doctor, but hopefully as an economist, what I've been trying to do for the last 10 years really, is bring the tools that we have in our toolbox as economists to the space sector. How can I use what I know as an economist to understand both where we've come from, why we find ourselves in a place where a business school professor is talking to medical doctors, as well as rocket scientists and astronauts about the business of space, right, which was definitely not happening 10 years ago, 20 years ago, 30 years ago. How did we get to this point, and then where are we headed? And so my big hope for my short time with you together this morning is to give you a couple tools that you'll take with you. So when you are thinking about space business or the economics of space, you can pull those out and they'll help you dissect what's happening and sort of structure your thinking on space, okay? All right, so the first thing, as I mentioned, let's talk for a few minutes about how we got to where we are today. And I'll try to do this pretty quickly because I know we're focused on the future. If you think of space, the space age, and I should also say, some of this is old news to some of you in the room. So apologies, but I will try to move quickly. Let's imagine you divide the space age in basically 3 acts. The first is 57 to the early 70s, so Sputnik through Apollo. If I asked you to think about adjectives for that era, what come to mind? Shout them out. Exciting. Heroic, right? Exactly. And the true. Maybe related, right? We spent a lot, we achieved a tremendous amount, and we have these visions. This is the decade in which Star Trek was created, by the way, for the other Trekkie fans out there. So this was an era of incredible aspiration. And if you look at what NASA was planning, or at least what it was commissioning as plans, and what the world was talking about in the early 70s, the dreams were truly extravagant, right? And it makes sense because in just a decade we had achieved so much. Imagine forecasting out at the time, the next decade and the next and the next and the next. Imagine by 2010 what they thought would be possible. Okay, so that's Act 1. Now Act 2, let's say Act 2 is the era of the Shuttle and the ISS, okay? So, mid-70s through mid-2000s. What are the adjectives you'd shout out about that era? Routine. Okay, good. Routine. Expensive. Expensive in a different way, perhaps, yeah. Anything else? Living in space, yeah. International, right, with the ISS. Grinding it out. No one's mentioned tragic, right? 2 shuttle accidents. So it's a really interesting era because, of course, there's a lot of nuance, and we want to be careful not to forget all the incredible achievements over that era, right? Amazing engineering achievements, personal achievements, and so on. But it's also hard, I think, not to feel that, at least relative to the hopes in the early 70s, much less was achieved over those 40 years, right? And the most painful part, of course, being the loss of the 2 shuttles and the crews, and then, as a consequence, the ending of the shuttle program. So remember I said, imagine in 1970 what they would have thought 4 decades hence, and instead of people on Mars and giant space stations, we didn't have a way to get Americans off of the ground, off of American soil into orbit, right? So what a tremendous moment of reflection and trying to identify what went wrong. So there's lots of theories and lots of stories, but I like particularly a quote from Jim Cantrell, which you guys might have heard. In the early 2000s, he was trying to diagnose what went wrong. He was early at SpaceX, and he said, "The great American space enterprise, which defeated communism in the defense of capitalism, was and is operating on a Soviet economic model." Okay? And so to an economist, that's a very trenchant statement because in the 60s, we had this centrally run, full force effort to do something very specific, right? To get to the moon. And it was incredibly successful. And if you look at the Soviet economy, that's how it ran. And in fact, it was incredibly successful for its first couple of decades in terms of industrialization. But then as time goes on, as you try to achieve a more diverse set of goals, as you try to do things that are innovative, that are efficient, that allocate resources effectively, that centrally commanded way of doing things just turns out not to work. The Soviets learned that about their economy. And we learned that about the space sector. That it turns out it's very hard to just run things from the center over time. And so what Cantrell was pointing to is that we needed to bring in market forces. We needed to bring in capitalism to space. And that's, when I think about Act 3, I think about that being the key thing that changed. So why am I here? Well, because in the mid-2000s, we started saying, and of course there'd been efforts to do this decades and decades before, but with the decline of the shuttle program, the urgency was there to actually start bringing in market forces. And so I think of Act 3 as being, say, 2005 to the present. And we talk about it in terms of the commercialization of the space sector. I've heard that word a lot here, and I think that's the right term. Just to be clear, it's not privatization, right? So it's not getting the government out of space. That's probably never going to happen, never should happen. But it's bringing in the commercial forces that really can drive efficiency and innovation. What are market forces? I won't go too much in depth on this, but the two that I would just highlight, if you think about the Commercial Orbital Transportation Services Program in the mid-2000s or Commercial Crew and Cargo that came after, there's two big things. The price mechanism. Okay, so prices are the kind of thing that make economists glow. Prices, we take them for granted, but, well, I should have asked at the beginning, how many of you have taken economics at some point in life? Okay, great. Okay, great. You know what I'm talking about. Prices aggregate unbelievable amounts of information on costs and benefits, right, that are distributed among each of us into a simple number that my daughter can understand, right, and everyone else, and make choices along. We didn't really have meaningful price mechanisms in space for 40 years. And competition. Though we try to get competition going, we didn't really have it in space in the way that we think of it in a competitive economy or in a market economy. And so those are a couple of the market forces that we brought in. Now, why does it matter so much to do this? Why is this revolution so important? Okay, so here's where, apologies in advance, but I'm going to bring out an economic tool from my tool belt. It's sort of the Swiss Army knife of economists. And the reason I'm going to do that is because of the chart that I inadvertently already showed you, which most of you in the room already know, which is the cost of launch declining so quickly. And you know, it's not an accident, right, that in the mid-2000s where I put the start of Act 3 is where you start to see this curve dip down. And if you I'm sure you've all seen this chart before, but if you haven't, it's also worth noting that this is a log scale, right? So we are really talking about dramatic reductions in the cost of launch on an order of magnitude already, and hopefully another order of magnitude going forward. Okay, so why did I start here? Well, first, because this is exactly the promise you would hope of bringing market forces in for innovation, for competition, that you would see the costs of doing things in space decline. But also because it lets me use my tool. And my tool is the supply and demand framework. And no one is smiling. Come on, folks. This is the main thing. If you're an economist, you should be lighting up when you see this. Okay, so most of you raised your hand, which means you've seen this graph before. It's probably also rusty for almost everyone who raised their hand, because I bet you took econ quite a while ago. So I'm not going to dig too much into the framework, but just to remind you briefly, imagine this is the market for space activities, whatever you want it to be, tourism, R&D, manufacturing, resource extraction, whatever. There's the price of doing space activities and how much of it we do, the quantity. That's what we're plotting. The demand curve is just that as the price goes down, more people are willing to buy. The supply curve is as the price goes up, more people are willing to supply into the market. And economists like to think of the demand curve as the benefit curve. So basically, I'm willing to buy when the benefit of this activity is at least as big as the price. And so you can think about each of those people deciding it's worth it for them to buy at a given price. Or another way, given our focus here, if I have a business, when am I going to buy space activities? When does my business case close, depending on the price of those activities? And the supply curve is the cost side in the sense that I'm going to be willing to supply space activities when I get paid enough to do it, right? When it covers my costs. And as the price goes up, more and more people will want to supply into the sector. Okay, so why did I do this? Well, because, of course, with the thing I just showed you, we can move that supply curve. Okay, we can push it, economists think of it as out, but it might be easier to think of it as down. The costs have fallen for any given level of space activity. So this is the promise, right? And I forgot to mention one thing, but it's probably obvious. The lovely thing about a supply and demand framework is that they cross. Supply and demand cross, and that's what economists call the market equilibrium, where the number of people who want to buy equals the number of people who want to sell. And when you can push the cost down, what's supposed to happen is you slide down that demand curve, you get more space activity. But what does that really mean? What does that really mean for people in this room? It means that more business cases are closing, right? More startups are able to say, actually, yeah, I could make a profit in space given that the costs have fallen. And the big worry, so this is maybe where we are today, but the big worry is that it's not working quite like that it's working like this. Okay, what did I do? I just made the demand curve steeper, or in other words, less responsive to the fall in price. Or in other words, fewer business cases are closing that we might have hoped would, even when I push costs down. That's the concern, right? That maybe, like what in fact is out there for us to do in space? How are we gonna generate real value for people here on Earth or for people eventually in space? Okay, I don't get as much quantity for the decline in costs. So what I wanted to do in the next maybe 5-7 minutes or so that I have left is give you a way to think about how companies are trying to solve this problem. Companies, people in this room and beyond. What could you do? And you could think for yourself for a second about what would you do? If you were looking at a framework like this, how might we get, in the sense, what we're trying to do is get that equilibrium quantity out. How would we actually do that? Okay, so I'm gonna give you 3 different ways to think about it. The first is to accelerate adoption. So I drew this curve as bending down, but what if we could tilt it back up again? Right? What if we could show people that in fact, as the cost of doing activities in space falls, more and more business cases close, more and more people could adopt the technology. And if you think about companies, so I've listed a ton of companies up here trying to do this. Planet's a great example, Earth observation, right? What is Planet doing? So first of all, they developed this amazing technology to image the Earth, at least once a day everywhere on the planet. But really what they need to do is find customers who want that data. That's like the big challenge for them once they get the technology set up. Okay, and so, and then all these other companies and many, many more similarly trying to do a similar thing. And let me just go back to the graph here. So there's a phrase or a term economists use to describe this. It's called the Le Chatelier principle. It's actually from natural sciences, so you might have heard it. But the basic idea is that over time, the responsiveness of economic activity is higher than it is in the short run. And there's some nuances underneath there that we could get into, but I think the intuition's pretty clear. Once you get people to start using something, they start to see its value, and then they can change how they're doing things to use that thing even more. And so this is a big part of what we're trying to do in space, and I think all of you can contribute to that as well. Option 2 says, well, okay, so maybe right now that demand curve looks like this. It's got this very steep slope. But maybe it turns out that if I could just push the cost curve out even further, there's a part of the demand curve lower down that is flattens out again. Okay, so it is true that we've lowered the cost of doing things in space. It's also still true it's pretty expensive to do most things in space, especially things involving people. But if you think about Starlink, for instance, right, one of the few truly successful business cases in space today, what's the key advantage? Why is SpaceX the one doing that? Because they charge themselves their costs of launch, not the price of launch, right? They have a much cheaper cost of putting that constellation up in space. I mean, there's other reasons SpaceX does it, because SpaceX is exceptional, but it is also because they're further out on this cost curve. And so there's all sorts of activities trying to do this, and you can think of this broadly. So for instance, commercial stations, I think is one of my favorite examples. We've already pushed the cost down in launch, right? But we haven't really pushed the cost down on stations yet. And we want to get somewhere in space to do these things we want to do. As we all know, there's these efforts to do commercial stations. There's a lot of uncertainty around them right now, but to me, that's a big area where we can hope to keep pushing these cost curve out and then find new applications. But there's all sorts of other places in which you can interpret things as pushing the costs down as well. Even things like firming up regulations or space debris management. Right? What are those doing? Well, they're lowering the cost of operations for companies so they can go do things in space. Okay, and then the third is, well, okay, maybe the demand curve does look like this. Let's just generate some new sources of demand. Let's do some stuff we've never done in space that even pays off at high prices, at high costs. And these are the sorts of things that light us on fire, right? So let's go to Mars, let's mine the moon, Let's do these things that are potentially, or space-based solar, right? Data centers in space, the things that could justify huge investments. And you see, various companies up there trying to do these sorts of big things. Okay, so I'm going to close with one other tool in economics. So just again to show you that. So those are sort of the three ways. And whenever you run into a startup, whenever you're talking about what you're trying to do with space medicine, I think one way to understand is to think, which of these three things am I doing to help solve this economic challenge? Okay, now how are we going to actually do that? And here's where I want to introduce this second tool that economists love. You guys know this game, the stag hunt game? Raise your hand if you've heard this game before. Okay, about a third of the people in the room. Most of you know the prisoner's dilemma game. If I put that up here, you would recognize that. If you've seen the movie about John Nash, Beautiful Mind, you would know that game. That's this very frustrating game, right, where these two prisoners, they keep wanting to cheat on each other. If they could just cooperate, they'd do better, but they can't. Right? They can't unless they commit somehow. Okay, the stag hunt is just a happier version of that game. And I think it's really trenchant for what we're trying to do here. So let me try to summarize it briefly. There's two hunters. They're hunting for either rabbits or deer, hare or stags. Okay, and these are the payoffs to the two hunters. So in the top left corner, the 1-1 means each hunter gets one payoff unit, whatever that is, for getting a hare. The lower corner is where lower left corner, hunter 1 has tried to hunt a stag by himself. Hunter 2 has stayed hunting the hare. So that's why we're in the lower left corner. The payoffs here, hunter 1, turns out you can't get a stag by yourself, so he ends up with 0. Hunter 2, turns out you can get a hare by yourself, so she ends up with 1. Okay, so we have 0, 1. 1, 0 is just the opposite. And then down the bottom right corner, they're hunting the stag together. That's how you get the stag. It's a bigger payoff. They each get 4. Okay, now the important thing about the stag hunt game, unlike Prisoner's Dilemma, so if you try to imagine what this would look like in a Prisoner's Dilemma, there'd only be one equilibrium. It'd be the bad one. It'd be hare. But if you look at this one, so that is an equilibrium. If we're both hunting hares together, I don't have any incentive to go try to hunt the stag myself. I'm not going to get it. So we stay there. But stag is also an equilibrium. If we're hunting the deer together, I don't have any incentive to cheat and go hunt the rabbit, hunt the hare. That's what's different from Prisoner's Dilemma. This is not an equilibrium, this corner of the game. And economists use this to think about how do we get from one equilibrium to another? How do we get from an okay place to something truly extraordinary? How do we get over that tipping point? And so I want to suggest that that's a good way to think about what we're trying to do in space, right? Go from a pretty amazing set of things we already do to something truly transformative. And luckily, there's actually pretty good ways to solve this. So if you start off in the hare, how do you get to stag? Let me show you. So imagine that you're a venture capital firm, or maybe a government, and you can take a bit off the top of the stag equilibrium. So instead of 4-4 in the bottom right corner, it's 3-3, either because you're venture capital carry or because of your taxation. And then you're going to use that money to incentivize risk-taking. So notice that the other thing that's changed is the zeros have turned into 2s. So now, if you start up there in hare, which is pretty good, you're both getting 1. If you take that risk to hunt the stag by yourself, I'm going to give you the 2. Right? So it pays off for you to take that risk, to try something bigger. Well, now it turns out the only equilibrium is stag. You're not going to stay in hare anymore. And I like to think of this as what groups like this are trying to do. We're trying to get into a room together where we can help each other figure out how to get to that stag equilibrium, how to take those risks on our own to do something really bold and really big so that we can enjoy the proceeds together. And that's it for me. So thank you very much.